Hey there, scholars. Welcome to another science lesson with me, Mr. Brace. Today we are going to be talking about making inferences when it comes to science. So, first, what is an inference? So an inference is an idea that is formed from facts or evidence. Facts are indisputable ideas. Evidence is proof that supports an idea. An inference is not a fact. It is a thoughtful idea that may or may not be true. It is not based on a personal belief or assumption. So you should be following along with a science notebook. If you do not have it, pause the video, go grab it now. And then the things that I underline are things that you should be writing out in your notebook. So first we need to write out the definition of an inference. So this first line, an inference is an idea that is formed from facts or evidence. And then we're also going to write out facts are indisputable ideas and evidence is proof that supports an idea. If you need more time to write those out, you could always pause the video. So now that we know what an inference is, let's talk about the process of making inferences. So when making inferences, it's an important scientific practice. Scientists ask questions about the natural world, and then scientists make inferences to answer those questions. Scientists make inferences to answer those questions. Scientists use observations to support their inferences. Let's write that out. They use information about the natural world to make a case for why they believe their inference answers questions about the natural world. Sometimes scientists conduct experiments to see if their inference is true. An inference that can be tested and proven or disputed is called a hypothesis. So, an inference is essentially a hypothesis. It becomes a hypothesis when we test it to see if it can be proven or disproven. So we've talked about what a hypothesis is in our previous lessons. So an inference is kind of like that. You're making an educated guess on what the answer might be. And then if you test it, it becomes a hypothesis. If you don't test it, it's an inference. Let's write that out. An inference can be tested and proven or disproven is called a hypothesis. An inference that can be tested or proven or disproven is called a hypothesis. Okay. So how do you make an inference using scientific observations? Many inferences are based on scientific observations. Scientific observations are objective. They are quantitative and qualitative characteristics about something in the natural world. Remember, quantitative means that we can have a quantity of something. We can have a number value, a measurement of some sort, whether you measure the length of something, the weight of something, there's some sort of number value. And a qualitative characteristic is using our five senses. What does it feel like? What does it taste like? What does it smell like? What does it look like? What does it sound like? Using all of your five senses to create these characteristics. So scientific observations are a form of evidence. Observations provide clues to help make a conclusion about what you think is true. Scientists cannot make inferences based on non-scientific observations, such as opinions, personal beliefs, or judgments. These things are based on emotions or feelings. They do not describe things that actually exist. So let's make sure to write out many inferences are based on scientific observations. Scientific observations are objective. And let's write out scientists cannot make inferences based on non-scientific observations such as opinions, personal beliefs, or just judgments. So let's practice a little bit. So if I'm making inferences, I can do it based on a picture. So I have this picture of a baby. So I can make scientific observations and say this individual is a baby. The baby is crying. And I made a spelling mistake. I don't know what happened there. So that is supposed to say baby. The baby is crying. The baby has light brown hair. The baby is wearing a striped shirt. I'm using my visual sense, my eyes, to describe what I see in the picture. And those are scientific observations. Non-scientific observations would be based on your opinions or how you feel about it. For example, that baby is cute. I don't like crying babies. Crying babies make me feel sad. Those are not scientific observations because they are you're using your emotions and your feelings to describe something. Now, an inference is I'm using my scientific observations and using evidence, previous knowledge. Now, as a father, I have 2 kids, so I've had 2 babies before. I can use my previous knowledge to understand why the baby might be crying. So I can infer, or I can make an inference that the baby is hungry, or the baby has a wet diaper. The baby is cold. Not a good inference would be the dog stole the baby's toy. There's not enough information for me to make that inference. In the picture, I don't see a dog or a toy. So I can't make that inference because there's not enough evidence for me to do so. All right, let's get a little bit more practice. So this is going to look similar to your activity for science today. I'm just using different pictures. So I have these 2 pictures, and I want to make some observations about them. And then I'm going to make some inferences about them. First, think about it. What are similar about these 2 images, these 2 trees? First off, they are trees in the picture. I can tell in both that both trees have fallen down. Both trees are laying horizontally instead of vertically like they normally would. Second question, what do you observe differently in this image? So referring to the first image right here, something different about it is this tree has a clean cut through it, and there's sawdust on the ground. I can observe that there's a sawdust on the ground, and it's in the forest. In the second picture, I observe that I can see the roots of the tree. It looks like the roots have come up, and there's dirt, and this is in a neighborhood because I can see a little mailbox right there. Now I ask, what do you infer about the tree in this image? in this image, I can infer that the tree was chopped down because of the observations I made. There's sawdust on the ground. It looks like a clean cut, and it's in the forest where we typically harvest wood. So I infer that the tree has been chopped down. Now, in the second picture, I can infer that the tree was knocked over, most likely due to a storm. I can see that the roots have been uplifted. I can also see that the street is very wet. So it looks like, and I can infer that the tree was knocked over because of a storm. Okay. All right, so what you're going to do is you're going to go take the do the science activity. We're going to do an activity similar to this. So I'll have two different pictures, and you're going to write out your observations about the two images. You're going to tell me what you observed differently about each, and then what you can infer about the image. Remember that you need to provide enough information to justify your inference. For example, in this first picture, I inferred that the tree was chopped down, but I can't infer that the tree was chopped down by a machine or by a lumberjack, because there's not enough information for me to tell you what chopped it down or who chopped it down. I just can infer that it was chopped down because of the evidence of the sawdust. Okay. All right, I'll leave you to it, and I'll see you next time.